Okay, question 4. Two particles A and B of mass m and 2m respectively are attached to the ends of a light inextensible string. Particle A lies on a rough horizontal table. String passes over a smooth P fixed at the edge of the table. Particle B hangs freely below the pulley. The coefficient of friction between A and the table is mu. The particles are released from rest with a string taut. Immediately after release, the magnitude of the acceleration of A and B is 4/9 g. By writing down separate equations of motion from A and B, find the tension of the string immediately after the particles begin to move. Okie doke. So, there's my pulley. There's a string. There's my particle A. Then here we got the particle B. Let's put forces on. So I'm going to have equal tensions. I'm going to have the weight of B, which is going to be 2 mg, and that's going to accelerate that way with an acceleration of 4g. And this one will also accelerate with that value. Then here I'm going to have a weight of mg, a normal reaction, and a friction. Okay, so there's my system. So Newton's law, second law, applies to both. So if we write down all our equations first of all, so on particle A, we're going to have the Newton's second law, which is the sum of the x components. So the direction of motion is positive, so I'm going to have t minus f equals ma. Excuse me. Vertically, everything's equal and opposite. So r minus mg equals 0. And I've got friction, and it's moving, so I've got the maximum friction equals mu r. Equation 1, equation 2, equation 3. So I've got 3 equations for particle A. And for particle B, I've just got Newton's second law. Direction of motion is positive. So 2 mg minus t equals 2 ma. And that's equation 4. So those are all my equations. The first thing they want me to do is to find the tension in the string and then work out the value of mu. So I need to end up in equation 3, but I can get, because I'm given the acceleration, I can get the tension in the string straight out of equation 4. So from 4, so I've got 2 mg minus t equals 2m 4g over 9. So t will be 2 mg minus 8 mg over 9. So if I took the mg out, that would be the same as 2 minus 8/9. So 2 minus 8/9 equals 10/9 mg. Now we don't know the value of m, so we would leave that in that format. So let me just check I agree with that. Yep, that's right. So that is part A. And then for part B, I need to keep going until I can work out mu. So R is mg, F, so from 1, F equals MA minus T. Well, I know that A is 4/9 G. So that becomes 4/9 mg minus T, which is 10/9 mg, which is wrong because it's F is T minus MA, sorry, so that's wrong. Rearranging that, the F is negative, take it over, bring the MA over, so F is T minus MA. So F is 10/9 mg minus 4/9 mg, because A is 4/9 G. So the frictional force is going to be 10/9 take away 4/9, which is 6/9. And 6/9 is the same as 2/3. So the frictional force is 2/3 mg. The reaction force is mg. So sub in 3, mu will be F over R, which is the frictional force 2/3 mg over mg. So the mg's cancel, leaving you mu as 2/3, which is what the question asked you to show, so as required. So that looks a long and complex question, but when you just break it down and get all your equations written, if you remember when we were practicing these, what I was always saying to you was don't worry about answering the questions, get all the equations down first, because all the marks are in getting your equations right, and then the secondary marks are for doing the manipulation. So hopefully you found that one not too bad.